Hello everyone, today we are going to find the Maclaurin series for the function gx, which is e power x cosine 2x up to and including the term in x squared. And we are also instructed to use the Maclaurin series for e power x and cosine x to help us with it. Now we don't really need to differentiate these terms individually, as it will take us quite some time to do so. So what we can do, however, is to refer directly to the MF26 formula sheet and to find the section on the Maclaurin series and make full use of the expansion of e power x and cosine x to actually help us. Now take this time also to make sure you are familiar with the rest of what has already been provided for you so that you can save precious time to employ them during the examinations. So e power x is simply 1 plus x over 1 factorial plus x squared over 2 factorial, and we are going to stop just right here because we are only interested in expanding up to the term x squared. So let's leave it here for a moment and try expanding cosine 2x instead. Now notice that it's 2x over here, but the angle in the formula is an x. Now what we can do is to simply replace all the x that you see to 2x. And now this gives us 1 minus 2x squared over 2 factorial. And don't forget to put these 3 dots over here because this is not the full expansion of cosine 2x. Now to get the function gx, all we need to do is to simply take the product of these two expressions. Now it's really quite straightforward. All we need to do now is to simplify up to and including the term in x squared. Now with that we have 1 plus x squared over 2 minus 2x squared, and this will be equals to 1 plus x minus 3 over 2x squared. Now in part 2, we are going to use this answer to help us evaluate the approximation in the case where a is equals to 1/3 e. Now integrating the function gx is approximately equals to integrating this expression over here. So be sure to include the approximate sign as the expression is not fully complete. Integrating this with respect to x, we will then have x plus x squared over 2 minus x cubed over 2, and don't forget to put the lower and upper limits over here, and this is approximately equals to a plus a squared over 2 minus a cubed over 2. Now this is not the final answer. We are going to substitute a equals to 1 over 3e into all these terms over here. We will then have this expression where the integral is approximately equals to this expression over here, and by using our graphing calculator to help us, this is approximately equals to 0.94464 rounded to 5 significant figures. Now very quickly in part 3, let's try to get the accurate value of this integral. And you realize that the calculator value gives us 0.64284, which is really quite different from the answer that we have found previously. Now the reason is very simple. There is actually insufficient terms over here, which is used in the expansion. Now if we were to expand more terms over here, the more accurate the answer will be. Now there's also another reason why the approximation is different. Now the value 1 over 3e is not close to 0, and this makes the approximation not a good one. Now I do hope you have learned something from this video. If you have any questions or comments, do leave them down in the comments box below, and thank you so much for watching.